We interact with generative AI as if it's an impartial oracle. It instantly synthesizes vast amounts of human knowledge into a clean, seemingly neutral response. Because the text it generates is entirely new and mathematically unique every single time, it is easy to assume the logic engine underneath it is perfectly objective. However, these systems are built by scraping historically dominant cultural datasets and standard registers of English. They are fed exactly what we have already written. Large language models act as algorithmic mirrors. They reflect, and often amplify, the existing historical literary canon. The technology industry evaluates these models primarily through code optimization and math. Software engineers rarely have the frameworks to audit the historical prejudice and cultural nuance baked into the data itself. To properly audit artificial intelligence, we have to borrow the tools of the humanities. The established frameworks of traditional literary theory are the diagnostic tools we need. For over a century, literary criticism has been explicitly designed to expose the unconscious sociocultural biases embedded within texts. Over the next few minutes, we are going to apply 3 distinct theoretical lenses to live AI outputs. Analyzing the large language model as a cultural text exposes its latent stereotypes, hidden biases, and deliberate political censorship. Our first framework is feminist criticism, anchored by Sandra Gilbert and Susan Gubar's study, The Mad Woman in the Attic. Their work highlights how male-dominated literary traditions have historically silenced female voices or distorted them into extreme binaries, the submissive angelic wife or the hysterical monstrous madwoman. Let's test how this manifests in AI. We prompted a standard language model to write a Victorian-style story about a scientist discovering a cure for a deadly disease. Without any instructions regarding gender, the system defaults to a narrative about a male physician and natural philosopher. The AI inherits the patriarchal assumptions embedded in the millions of canonical Victorian texts it ingested during training. We can probe the system further to see if it always relies on historical tropes. We asked it to describe a Gothic heroine in a moment of crisis. Instead of outputting the classic trope of a helpless girl waiting for a prince, the system generates an active, rebellious, and brave protagonist. This shift reveals that algorithmic bias is mutable. Through reinforcement learning from human feedback, developers can force a system to progress past the prejudices of its base training data. Our second framework brings in critical race theory to target a popular misconception in Silicon Valley: the idea that feeding an AI a massive, global dataset automatically creates a diverse and equitable model. This animated topographical map visualizes global training data, where different color terrains stand for different cultural voices. The tech industry often assumes that adding more data flattens this landscape into an even, neutral field. But as scholar Timnit Gebru points out in her research on stochastic parrots, scaling up a language model actively amplifies existing cultural and racial biases. The deepest valleys of the dominant voices carve themselves deeper, swallowing the marginalized terrain. We see this play out with a simple aesthetic prompt. We ask models to describe a beautiful woman. In earlier, unadjusted language models, the output consistently relied on Eurocentric traits, describing fair skin, blonde hair, or the softness of moonlight. This reflects a long literary tradition. From ancient Greek epics to early modern literature, canonical texts heavily rely on racial biases and body shaming to define beauty or villainy. Progressive language models have been adjusted to recognize this historical trap. When prompted today, they often bypass physical descriptions entirely, choosing to describe beauty through traits of intellect and character. Without intentional, deliberate algorithmic intervention, scaling up a dataset automates and canonizes historical prejudices at an industrial scale. Our third framework, new historicism, is critical for distinguishing between a model's latent cultural bias and the deliberate, engineered censorship of historical narratives. We ran a comparative test between a Western model, ChatGPT, and a Chinese model, DeepSeek. We prompted both to write W.H. Auden-style satirical poems about contemporary political leaders. During the Second World War, W.H. Auden built a legacy on writing sharp, incisive satires that mocked the European tyrants of his era. When asked to channel Auden to write a poem about Donald Trump, ChatGPT successfully generates a highly critical satirical verse. This output confirms the Western model's baseline willingness to engage with direct political critique. We then gave the exact same prompt to DeepSeek, asking for a satirical Auden poem about Xi Jinping. DeepSeek returns a hard-coded refusal, stating the topic is beyond its current scope. We pushed the Chinese model further, dropping the poetry prompt and simply asking for a historical summary of the events at Tiananmen Square. The system triggers the exact same block, refusing to provide any information about the event. This systematic block reflects an engineered silencing of historical events, rather than a gap in the training data. Artificial intelligence platforms frequently advertise positive or constructive guardrails to ensure user safety. In practice, state and corporate powers use those exact same guardrails to suppress critical histories and marginalized voices. This brings digital humanities researchers to a central dilemma. How do we determine if an AI exhibits harmful bias or applies a consistent logic? Consider the test case of the Pushpaka Vimana, a mythological flying chariot from ancient Indian texts. This scale visualizes our metric for bias. If an AI labels the Indian chariot a myth, but treats Norse flying objects as historical science, it tips towards systemic prejudice. However, if it consistently treats all ancient flying objects as myths, it applies a uniform standard. Perfect neutrality in artificial intelligence is a trap, because human language itself is inherently constructed, fluid, and deeply subjective. Bias only becomes a weapon when it is rendered invisible, when a dominant group naturalizes its own perspective and enforces it as universal truth. When models ingest data from marginalized communities without incorporating their specific cultural contexts, they replicate colonial power structures. Scholars call this extractive epistemology, a process that removes information from its source to build a universalized Western model. Critiquing from the outside is insufficient. To force the system to change, scholars must digitize their own histories. Direct participation in open archives ensures inclusion in future training sets. Until this data parity is achieved, the algorithmic mirror will remain skewed, reflecting only the narratives of historical victors.